Over the next couple of videos, I will be explaining multiplying binomials in lots of different ways. Here's the first way. Let's say I have x plus 3, and this whole thing, this whole quantity, is multiplying 2x plus 5. How do I do this? So the first step is we're going to multiply x times 2x. The second step is we're going to multiply x times 5. The third step is we're going to multiply 3 times 2x. The final step is we're going to multiply 3 times 5. And we're going to add all of these. Have you heard of this thing, FOIL, FOIL? It's a memory aid. It's taught in some math classes. It's not always taught, but I'll explain it really quickly since a lot of people like it. The F in FOIL stands for first. So we are multiplying the first terms. X is the first term. Like in this set of parentheses, X is the first term, and 2x is the first term, right? In this set of parentheses, 2x is the first term. And we're multiplying these. We're multiplying x and 2x. We did it down here. The O stands for outer because we're multiplying the outer terms. We're multiplying x and 5, right? We did that down here. The I stands for inner because we multiply the inner terms, 3 and 2x. We did that right here. And the L, that stands for last because we multiplied the last terms, right? We multiplied 3 and 5. These are the last terms, right? In this set of parentheses, 3 is the last term. In this set of parentheses, 5 is the last term. And we multiply these terms. We did that right here. So hopefully this abbreviation, this acronym, helps you remember what I just showed you. And if it does it, that's fine as well. This is not necessary. It's just a memorization tool that a lot of people like. It's not essential to being able to do these problems. Okay, so I think we can simplify some of this stuff. X times 2x is 2x squared. X times 5 is 5x. 3 times 2x is 6x. 3 times 5 is 15. And I could write a multiplication symbol here, right? I'm choosing not to. We can add some like terms here, right? If we have 5x's and 6x's, then how many x's do we have? 11 x's. 2x squared plus 11x plus 15 is our final answer. Here's a second explanation. Let's say I have 2 plus 3 times 4 plus 5. How would I do this? Well, 2 plus 3 is 5. 4 plus 5 is 9. 5 times 9 is 45. That's the answer. Okay, there's another way you can do this. Let me show you. You can do this really weird multiplication thing. Some people call this like FOIL. 2 times 4. 2 times 5. 3 times 4. 3 times 5. And if we add all these things up, I know it seems crazy, but we actually get the right answer. 2 times 4 is 8. 2 times 5 is 10. 3 times 4 is 12. 3 times 5 is 15. I guess I'll write it like this. So this is 15, carry the 1, 45. So we get 45, which is what we got here. We got the same answer. This crazy way of doing the problem works. So what if we had letters? What if we had like x plus 3 times 2x plus 5? Well, I think we could do it the same way we just did this. I know we have letters here, but it really doesn't change a whole lot, right? Like, remember that in math, letters are supposed to be numbers, right? So if we have a cool trick that works here, then why wouldn't it work here? In both cases, we're basically just dealing with a bunch of numbers. So let's do it. X times 2x, x times 5, 3 times 2x, 3 times 5. Let's add everything up. And this problem continues. I will not show the rest of it because I already did it. I did it in the first explanation, and this was the answer. Here's the third explanation. Do you remember the formula for distributing? This is it right here. Can we use this formula to do a problem like this? The multiplication sign is not necessary. I guess I'll erase it. I think we can use this formula to do this problem. Does this look that different from this? I don't think so, because it's just like instead of having a, we have x plus 3. So in other words, basically, a is x plus 3 for our specific problem. And instead of having b, we have 2x. So b is 2x for our specific problem. And then instead of having c, we have 5. So c is 5 for our specific problem. And the formula tells us the answer. This is like the generic answer. So a times b plus a times c. Now, wait a minute. What is a? A is x plus 3 for our specific problem. So I'm going to replace all the a's with x plus 3's. And what is b for our specific problem? It's 2x. So I'm going to replace b with 2x. And what is c for our specific problem? It's 5. So I'm going to replace c with 5 for our specific problem. And now this is like normal distributing. Well, maybe it looks a little bit different than you're used to because like the orders kind of like flip. So let me write it in a more normal order. I can switch the order when I'm multiplying, right? The order in which we multiply doesn't matter. We still get the same answer. So now this looks like normal distributing. So I'll do this pretty quickly. If you don't remember, or if you never learned how to do like normal distributing like this, check out my video on distributing. I explain distributing in 5 different, or is it 5 different ways? I think it's 3 different ways, but check that video out. I'll link it in the description. We can add like terms here. 6 x's and 5 x's means we have 11 x's, and this is our final answer. Okay, I have more explanations to come in the next video. Thanks for watching.